right, 9, September 2, 9, 2, 2021, okay? Our objective today is solving two-step equations. Okay. So, these are like boxes. We don't know what's inside the box. These are like boxes. So if I have x on both sides, here's my equal signs. See? There's that. This is not 2x plus 4x, right? It's not. If they were together, we'd add them. Does that make sense? It's not the same. They're on other sides. It's not 2x plus 4. I would make that a 6x, but it's not. This is not this. They're on both sides of the equal sign. So what I'm going to do is take away two x's, two boxes, take away two boxes. I'm just going, okay, I will subtract 2x, subtract 2 x's. Boxes with boxes, x's with x. Okay, x's with x's. Okay, and then that'll cancel out. We'll remove that box, right? Bring down the -5. Just bring it down. 2 x's are gone. Bring down the equal sign, which is like the balance. Bring down the 17. And then I took away two boxes. I took away 2 x's. So I'm left with plus 2x. Okay? So even though the x is on the right-hand side, that's okay. I'm still solving for x. I don't care if it's on the right-hand side. I just want to get rid of the numbers around it. Does that make sense? So I'm going to get rid of the numbers around it. So I'm going to get rid of the 17 first. The 17 is kind of hanging out. It's a regular number. It's a whole number. So I'll subtract the 17. -5 minus 17 is a -22. 17's gone. Equals 2x. Now we're going to make some helium, right? Because what's in the box is going to be negative. So divide by 2. Divide by 2. And -11 is what x happens to be. Thumbs up. Can I see? Thumbs up. Does that make sense? Does that make sense? Okay, any of these? I'm okay with these. Mr. Davis, sideways. Sideways thumbs. Sideways thumbs would be good. Okay, no, Mr. Davis, I hate math. Can't do this, right? Mars, you're good at math. Okay. Let's take a look at number 2 then. Okay, number 2 is different. It's different because if I go plus 9x, there'd be nothing left on this side, right? So let's get rid of the 4x. Not the 10 yet. Not the 10 yet. Let's get it down to just one set of x's, okay? So to get rid of the subtract 4x, we always do the opposite. To subtract 4x, what's the opposite? We're going to go plus 4x, right? It'll go on the other side, plus 4x, okay? So when you add 4 boxes, you add 4 boxes. You've got to keep it balanced, okay? So then this subtract 4x is gone, right? We just eliminated it. I'm going to bring down the 10. 4x is gone. Bring down my equal sign. And then what is -9x plus 4x? -5x. Good answer. -5x, there's an invisible times, right? They're right next to each other. They're right next to each other. It means being multiplied, right? So we did the opposite. So I'm not going to add. I'm going to divide. Opposite, because there's an invisible times sign. -5 times x, so I divide by -5 on both sides, right? That'll cancel. Psh, negative, 5 just cancels. And then we're just left with x. 10 divided by -5 is -2. Okay. Okay, let me see. Thumbs up, sideways, thumbs down. Where you at? Okay, good. I always want you to be honest with me, okay? I do want to emphasize that we have Flex. Flex is such a great time for you guys to hang out. But if you need help, come see me, okay? All right, example 3. I got T's. Well, these are just, again, same thing. They're on both sides, right? I like to get rid of the smaller one first. I like to get rid of the smaller one because then I get positive numbers. And negative 5 is smaller than positive 5, right? You don't always do this, but I like to get rid of the smaller. You don't have to, but I like to get rid of the smaller one. So I'm going to go positive 5t because that will cancel that out, right? And of course I've got to add 5t to that side too, right? 5t plus 5t is 10t, right? Bring down the plus 16. Bring down the equal sign. Bring down the 6, and negative 5t is gone. So here's my t. Let's get rid of all the numbers around it. Okay, I've got one t, one variable t. I've got all these numbers around it. Let's get rid of the numbers around it. Get rid of the numbers around it, then I'll have t by itself. So, okay, minus 16, because that's the opposite of plus 16. Same thing over here. I'll go minus 16. Cancel out, right? It's gone. I'll bring down the 10t. I'll bring down the equal sign, and negative 6. 6 minus 16 is a negative 10. 10t is 10 times t. There's an invisible times sign. So we undo it, do the opposite of times by 10. We divide by 10. Cancels on both sides. 10 divided by 10 is 1, but we've got a negative 1. Okay, again, I want to see where you're at. Be honest with me, okay? If you're sideways, that's okay. If you're thumbs up, okay. Thumbs down, okay. It's good to know. Okay, thank you for being honest. Okay, now, example 4. They just get bigger, that's all. You remember the one I did on the board the first day? That's pretty big, right? Look what we're doing. They're getting bigger, aren't they? But we can do these as long as we have a plan. So I mean, the first thing I would do, what would be the first thing you would do on this one? Yeah, what would you do first?
Roughly times 10 by z and then times 10 by 5.
Yeah, so we would distribute, okay? Yeah, we distribute. Okay? Preston, you were going to say that, weren't you? And distribute over here too. Let's distribute both. I really like that idea. Okay, so then if we multiply 10 times z is 10z. Because it's multiply, right? There's my invisible times sign. 10 times 5 is a positive 50, okay? Equals. And again, we'll distribute. 2 times z is a 2z plus 2 times 9 is positive 18. Okay, then it's just what we've been doing, right? So we can do big equations as long as we have a plan and a strategy. Okay, so then 10z, 2z. You could get rid of either one, but I like to get rid of the smaller one. I do. I like to get the smaller one. It's like move boxes. So minus 2z, right? From both sides. (10z minus 2z is 8z. Bring down the plus sign. Bring down the 50. And these two are gone. My z's are gone. 2 z's are gone. Bring down the 18. Okay, here's my z. I want it all by itself, so I want to get rid of all the numbers around it. Okay, here's my z. Let's get rid of all the numbers around it. So let's get rid of the plus 50. So let's do the opposite. What's the opposite of add 50? Subtract 50. Minus 50. Okay. So my 50 is gone. And I've got 8z equals, let's see, what's that? A negative 32. Is that negative 32? I think it's negative 32. Again, if you're not sure, you can always use a calculator, if you get stuck. So, okay, what is 18? Subtract 50. Yeah, what do you know? Mr. Davies can do math. Okay, and then 8z, there's an invisible times, right? So we undo it. We do the opposite. So we divide by 8 to cancel it. And, of course, we come over here and divide by 8. We'll get z equals negative 4. How's that? Okay, let me see again. Thumbs up. I like thumbs up. Thumbs up is good. It's okay. Downways thumbs are all right. I mean, sideways thumbs tell me too. Okay, good. All right, nice job. We're getting there. Okay, so turn the page. Fractions. Fractions. We can do fractions. Okay, now, there's 2 ways to do fractions. Actually, there's lots of ways. Yeah, I'll say 2 ways to do fractions. Okay? we can take 1/4 of 32, which is the same thing as taking 32 divided by 4. You get that? I can take 1/4 of 56, which is the same thing as dividing 56 by 4, okay? You can also use a calculator. That's the second method, okay? You can also use a calculator. Calculator's okay. If you can't figure out 1/4, just change it to a decimal. I don't mind calculators. You guys know that. You can use a calculator, but let's distribute first, okay? So we're going to distribute that times that times that, and 1/4 times that, and 1/4 times that. So I'm going to distribute first. All right. 3 times 3 is 9, so I get a 9x. 3 times 4 is 12, but it's a subtract. It's still a subtract 12, okay? 3 times 4 is 12, but still subtract. Okay, now, equals. Okay, 1/4 of 32. It is 8, but if you're not sure, you can use a calculator. Okay, you can go 1/4 times 32. You can use a calculator, I don't care. Well, I didn't get 1/4, did I? Try it again. 1/4 times 32, and I get 8, okay, right? Or just divide 8x, and then 1/4 of 56, right? Or what's 56 divided by 4? Same thing. I get 14, okay? I don't mind if you use a calculator, so plus 14, okay? Now, x is on both sides. You can get rid of the 9 or the 8, it doesn't matter. I like to get rid of the smaller one. That way I keep things positive. So I'm going to get rid of the 8x, okay? So I'm going to go minus 8x. Minus 8x. And I'll get 9x minus 8x is a 1x. Bring down the subtract 12. Bring down the equal sign. That's gone, and equals 14. Now 1x and x are the same thing. 1x and x are the same thing. You don't have to write the 1. You do not have to write the 1. But I am going to go plus 12 plus 12. Of x equals 26. Okay? How's that? Aside from the fraction, okay? And you can always use a calculator on the fraction, okay? How's that? Okay, good. Mars?
So, would these ever be decimal points or no?
Oh, yeah. Yeah, in fact, they can be any number, right? They can be. I have learned, okay, as a teacher, you'll appreciate this. The concept I want you guys to learn is doing the math. I'm hoping you already know how to do decimals and fractions, okay? But it can be, right? And I've learned as a teacher, as soon as I start putting fractions and decimals in, then kids go, ah! Right? They freak out. So if I just keep it to good numbers, then we can learn the concept more easily. You're right, Mars. It could be anything, right?
Also, would they ever be like plus instead of equals or divide instead of equals?
I don't know what you mean, eh? You can
Like
explain it.
3x plus 3 instead of equaling 12 plus 3x. Or something like that.
Yeah, we'll combine terms later. Yes. Yeah, we're going to do that later, okay? I know what you're talking about. Okay, how about example 6? Okay? What do you want to do? Example 6 is a trick question. Just warning you, okay? What do you want to do? Somebody tell me. What am I going to do? Anybody? Yeah, Tava?
Minus 3x on both sides.
Yes. Okay, now something is not going to be right. You're going to get no x's. Okay, no x's. Right? So here's the dilemma. You can't solve for x. There's no x's, they're gone. And this is a math class. Come on now. Does 3 equal 12? Will 3 ever equal 12? No. So this is no solution. X's are gone. That doesn't make any sense. X's are gone. So we're going to say no solution. And this little symbol, if you don't like to write, I like symbols because I'm a math guy. This little symbol means the same thing, okay? But you got to have the line through it, otherwise it looks like 0, right? Or just write no solution, okay? Okay, example 7. Another trick question. I'm just going to forewarn you, okay? So I'm going to distribute, right, first. I'll get a negative 8y. Negative 2 times 1 is a negative 2 equals a negative 8y minus 2. I don't know about you, but that looks weird. That just looks wrong. I mean, really? It's the same equation, right? Twice. You guys see it twice? And if that happens, no matter what you plug in for y, it'll always work. I'll say it again. You plug in 1, plug in 0, plug in 3. It'll always work. You plug in any single number for y, since they're equal, it'll always be equal. You can plug in any number. I can plug in 0 and have negative 2 equals negative 2. I can plug in 1. Negative 10 equals negative 10. I can plug in 2 and I'd have negative 18 equals negative 18. I can plug in any single number I want. It's always going to work, right? You see that? So if it's any number, we're going to say the solution is all real numbers. And that only happens if you get the left-hand side to be exactly the same as the right-hand side. Okay, so we have time today. I want you to go to page 15 in your journal. We'll do 1 to 14 all, and the extra is number 15. Okay, I want everybody